Now in section 7.6, we're going to graph what's called a system of linear inequalities. So we've graphed linear inequalities before. When we graphed linear inequalities, it looks something like this, where we graphed either a line or a dotted line, dashed line, and we used a test to point. We decided whether the origin worked most of the time, and then we shaded one way or the other. When we shaded, we said that all these things right over here are solutions, and then any point you chose over here was not a solution. And here's another graph that same thing's been done. They figured out that there's solutions over here. Any point over here works. Anything over here doesn't work. Now, today what we're going to be doing is we're going to be, if you can imagine this, we're going to be overlaying these. And they don't go perfectly, but if you can imagine overlaying these on one another so that we're going to find out of the two shaded areas, where do those two shaded areas intersect? So let's go ahead and make some real brief definitions here. A system of linear inequalities is this. We know what a linear inequality is, but a system looks something like this. It's two or more linear inequalities. That's pretty much what it is. Let's call it that. Now, a solution of these two linear inequalities, and I tried to show that over here earlier, is something like this. A solution is an ordered pair that is a solution of each inequality. Now, when I say this, I just want you to write one more thing down here, and that's this. Write down it's where the two shaded areas meet. So it's going to be a really, basically a darker shaded area in this case. And then let's go ahead and write down our basic procedures that we're going to have. It looks like this. If we graph a system of linear inequalities, in other words, just a couple linear inequalities on the same graph, it's going to look like this. The first thing we're going to do is we're going to graph the boundary lines of each inequality. Then we're going to use a dashed line. We know this from earlier. If the inequality is less than or greater than, and we're going to use a solid line if it's less than or equal to or greater than or equal to. Okay, that seems pretty easy so far. Step 2 says we're going to shade the appropriate half planes for each inequality. Now, nothing here is new. Nothing from step 1 and step 2 is new. The step 3 is a little bit new. We're going to identify the solution of the system of inequalities as the intersection of the half planes. So I'll give you a quick example of what that might look like. So here's the example. If you can imagine, yours will look a little bit different than this, but if you can imagine, whoops, not that one, that you graphed one inequality and it went like this. You had this line right here and you shaded all this right here. All that to the right. So the test told you want to shade all this stuff right here. But then over that, we're going to lay this line right here, and what we're going to see is that we found out that it shaded all this stuff down here. So all of this was shaded below this line. If you can see this, where the red and blue lines that I'm drawing are crossed, everything in that area from here to here and forever, all this in here is going to be a solution. Any ordered pair we took there is going to be a solution for both inequalities.